Today discussed about the previous NEET and MSET, AP MSET physics questions for subject physics. So here the chapter 1 in physics, physical world, units and measurement, right? So here the first question is strength of gravitational force compared to strong nuclear force. Compared to strong nuclear force. Option A 10 power minus 39, 10 power minus 13. Option B. Option C 10 power minus 2. Option D is 1. Understand? So once again, so strength of gravitational force compared to strong nuclear force, right? So the forces will be classified in generally in the universe is 4 type. Already you know that, right? So here to compare that gravitational force with a strong nuclear force, right? So the first of all, the gravitational force is Fg. You can take the gravitational force in the order of gravitational force is 10 power minus 49 Newton. Understand? So you can compare that gravitational force is a 10 power minus 49 Newton in the order of Newton form, right? So here another force is strong nuclear force, right? So here the strong nuclear force, here the strong nuclear force in the order of 10 power minus 10, 10 power minus 10 Newton, 10 power minus 10 Newton. So we can compare that. So how many times then be increased? So multiples. So if you take Fg by Fn, Fg by Fn, so that is equal to Fg is 10 power minus 49 Newton by 10 power minus 10 Newton. Understand? So here Fg is equal to, right, so Fn into, you can take the cross multiplication, 10 power minus 10 is a plus 10. So here Fn into 10 power minus 49 plus 10. So here the Fg is equal to, Fn is the how many times? 10 power minus 39 times. Understand? So that means how many times of gravitational force will compare to that of strong nuclear force. So Fg is equal to Fn into 10 power minus 39. 10 power minus 39 means here option A is the correct answer. Understand? So the answer is, the first question answer is 10 power minus 39 times. 10 power minus 39 times of strong nuclear force is equal to gravitational force. That means the gravitational force is equal to 10 power minus 39 times of strong nuclear force. Strong nuclear force. That is the answer now. Here. So how can, first of all you can write gravitational force and strong nuclear force and you can compare them. Okay, you can find the ratios. So that will be, you can calculate the option A is the correct answer in the first question, right? So here we can go to the next second question. So what is the given that second question is here the dimension of epsilon naught r. So the epsilon naught is called the permittivity of free space. Understand? So here the nuclear forces already know that 1 by 4 pi epsilon naught. The value of 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. In the order of 9 into 10 power 9. So here the Coulombic forces between the two charged particles, that means two charges, the Coulombic force formula is F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. You know the force of between the, that means electrostatic force between the two static charges Q1 and Q2. The distance is smaller. Understand? It is the Coulomb's law. You know that it's a Q1, it's a Q2. The charge is Q1 and Q2. Two charges are separated, the distance of is smaller. Already know that, right? So that's why you can using this calculation of epsilon naught, the dimension formula of epsilon naught, right? So here the, you can write the formula of epsilon naught. You can write the epsilon naught formula. Epsilon naught is equal to Q1 Q2 by Q1 Q2 by 4 pi F. Understand? Epsilon here you can write epsilon naught. So F is cross multiplied and then here you can write 4 pi F into 1 by R square into 1 by r square. You can write the dimension formula of q1 q2 4 pi f and 1 by r square. Understand? So you can substitute them. So what is the q1 q2 are two charges. Understand? So the dimension formula of charge is here q1 q2 charge order dimension formula. Here q1 charge is equal to, understand, charge is equal to, so if you write the electric current I is equal to q by t, already know that. Here q is equal to it. So it's a dimension formula of q is equal to I is a current amount, here the ampere capital A power 1, t is a time interval capital T power 1. That means the dimension formula of q is a1 a power 1 t power 1 at. So here you can substitute the q1 and q2 is the at. So that one means a power 1 t power 1. So epsilon naught is equal to, write the dimension formula, a power 1 t power 1 whole square. So those are charges. Understand? q1 q2 are quantities of charges. So you can write a square by 4 pi is a constant. Here the 4 pi is a always constant. So do not write any dimension formula, does not any dimension formula you can represent. So force, the dimension formula force is m power 1 l power 1 p power minus 2. Understand? F is equal to ma. So here you can write m place m power 1, a place l t power minus 2, l t power minus 2 into 1 by r square means l square, distance square. Okay, so if you write them, clear the dimension formula is, so epsilon naught to the dimension formula, epsilon naught is equal to, here a power 1 t power 1 whole square. So if you write a power 1 t power 1 whole square is equal to a square t square by m power 1 l power 1 t power minus 2, here l square l power 1 l cube. So m power 1 l cube, understand, t power minus 2, t power minus 2. So if you write m power minus 1, if you take a denominator in the form of numerator, m power minus 1, m power minus 1, l cube is l power minus 3, t power minus 2 is a plus 2, so t power 4 a square. Understand? That means a power 2. So here you can check the option m power minus 1, l power minus 3, t power 4 a square, that means a power 2. So option A is the correct answer. M power minus 1, l power minus 3, t power 4 a power 2. Understand? So it is the second one solution. So if you write the given parameters, understand, so if you take the correct formula and you can substitute the equivalent dimension formula in every equation form, so every parameters, understand. So you can get the dimension formula of epsilon naught here, right? So these are the two questions for last APM set questions. Understand? So now we can take to third question. So we can move to third question. So here the third question is, so which one of the third question, which of the following is not a, which one of the following is not a unit of time, here, understand, which of the following is not a unit of time, right? So here option A is a lunar month. Option B light year. Option C leap year. So option D is the microsecond. Here the microsecond. Understand? So first one is a lunar month, light year, leap year, microsecond. So which one of the following is not a unit of time? Understand? Which one is not a unit of time here? Right. First of all, so which one is the unit of time? You know that, right? So lunar month is the unit of time. It's a represent a particular time period. Understand? So it is a unit of time. Here given that month, clearly you can know that. Right. Second one, light year. Light year. So light year means, so in a vacuum, right? A light ray travel in a vacuum for a 1 year. The distance traveled in a 1 year is called light year. Understand? So it is a unit of time or a distance. Understand? Unit of distance. So it is clearly the distance traveled. The definition in the form of the distance traveled in a 1 year in a vacuum. Understand? So the light year can represent the unit of distance. It represent the unit of distance. Does not a time. It's does not represent a time. Okay, next we can third one, leap year. So already know that the leap year is 4 years once the leap year is occurring, right? So the leap year is the time period. Clearly time, days, number of days can be represents. So leap year is a time, unit of time. It is also unit of time. So the microsecond is the 1 by 10 power 6 times of 1 by 10 power 6 times of second, 1 second, or 10 power minus 6 second is called microsecond. Understand? So here the second is the unit of time. Second is the unit of time. Already know that, right? So here also the microsecond is the unit of time. Understand? So these three physical quantities, these three parameters are represent a time. The unit of represent of a time, but not represent a unit of time is a light year. Understand? So light year is the distance, the traveling distance of a light in a 1 year in a vacuum. Understand? So here that a light year is a unit of distance. It's not a time. Understand? So the correct option, which one of the following is not a unit of time? Here asking, so which one is not a unit of time? So answer is the light year is not a unit of time. It is a unit of distance. It is a unit of distance here. Understand? So it is also for a theoretical and important last year previous question, right? So in this way I can explain the each and every corner of a subject, right? Everyone can explain the further videos. Understand? So like my videos and share the videos regularly. I can update every videos in a day by day for a completed syllabus, MSET syllabus here, right? So like my channel and share the video. Thank you my students, everyone.